How's it going, guys? We're going to talk about some net ionic equation problems today. Usually the prompt that I've seen is write the molecular ionic and net ionic equation for these, and they'll give you the first half. So I usually just like to write them down the side, the molecular, the ionic, and then the net ionic. Do them one at a time like that. Now the easiest step to start out with is write the molecular formula. The molecular is going to be pretty much exactly like how you see it above on the first half on the reactant side. But I like to give a little extra space just in case you have to write numbers in front of these compounds. So before I even complete that first one, I'll usually jump down and do the ionic, just because that will make the next part easier. So first of all, we have lead. Can be 2 plus or 4 plus, but we know in this context it has to be a 2 plus because there's 2 of the NO3, and the NO3 here is going to be a 1 minus. So that's the first half. Then we have the sodium, the 2 sodium here, and the CO3 we know is going to be a 2 minus, so we can 2 minus. And then this has to be a 1 plus. 2. And then there's skinny little 2 there. 2 NO3. So now that we have all of our charges written out, it makes it a lot easier to move them over. So for instance, for the almost all of the ones that I've seen for these types of problems have been a double replacement situation where you're going to take the cation from one and put it with the anion on the other. So I like to do it chronologically or from right to left. So start out with the PB, it's a 2 plus, and then it's going to go with the CO3, which is a 2 minus. So that should be the 2 plus from the PB and the 2 minus from the CO3 should balance out, so it'll just be PB CO3. No need for parentheses or exponents or anything like that. Now we'll have the cation from this one with the anion from this one. So start off with sodium, Na, which we know is a 1 plus charge. And the NO3 is going to be a 1 minus. So this kind of works out as one of the easier ones in terms of balancing the charges. But before we move forward, we want to make sure we have the right number of each element. So we have 1 lead, 2 NO3s, only 1 NO3 over here. You can do it in different ways. I like to sometimes do the cations first and then the anions. So for the Na, we know we're going to need 2 over here because we have 2 here. So we can just start by putting a 2 there. Then we have 2 Na, 2 Na, 2 NO3, 2 NO3, and 1 CO3, 1 CO3. So that's all balanced, that's all set. Now the tricky part, I think, sometimes can be figuring out which is going to be like the quote-unquote product and which is going to be dissociated in terms of the ionic formula. In this case, it's going to end up being the PB CO3 because that is going to be insoluble, assuming this is a solution. Sometimes they'll put the states of matter and everything. Sometimes they won't. PbCO3, in that being because I think 2 Na plus 2 NO3 minus. Almost always with an NO3, anything is going to be soluble. There's, I think, only a couple rare cases, so that's usually a safe bet if you're not sure. So yeah, now for the net ionic, you basically are just going to cross out the spectator ions from the previous ionic equation. So now if we are going with that as our actual product, we just take whatever that came from. So from the ionic equation, Pb2 plus CO3 2 minus, it's balanced, it's all set. This is kind of like the best case scenario, I think, for some of these problems. Now we'll jump down to number 2 here. This one Yeah, same. I guess I kind of like to start them the same way every time. Molecular, ionic, net ionic. I think even if they only ask for the ionic or the net ionic, it's sometimes easier to work through it this way, in my opinion. So like I said, the first way to start, just kind of copy down what you see above SO4, but give some extra space. KOH. Now for the ionic, Cu, it's going to be a 2+, I believe. 2+. Then the SO4, going to be a 2-. But again, if you know one and you don't know the other, you can sometimes use it as a reference, because this would be an SO4 2 if this had a +4 charge or something. So kind of work it out that way. Potassium, I believe, has a 1+. Yep, potassium is 1+, and then the OH is always a -. So again, if we're doing a double replacement, we can take the cation from one and put it with the anion of the other. But this is not going to work out as simply as the last one, because as you can see now, the charges are a little bit different. So for Cu, it's a 2+, and for OH, it's going to be a -. So we're going to have to do the Cu, and then you can switch the numbers. Like that's one of the strategies. For the OH is a 1, so you'd have a 1 there, and then the Cu has a 2, so you'd bring it to the other side. Or you can kind of just think it out mathematically. But either way, you're going to want a parentheses around the OH, because you know, that's a single ion, I guess. Well, not, I'm sorry, it's a single molecule that's going to be bonded together. So Cu, so copper, I think it's ox. I'm not actually sure the name, sorry. So it's CuOH2 plus. Now let's put the cation, or the anion from one with the cation of the other. That's going to be K plus with the SO4. It's kind of the same deal. We're going to need 2 Ks. I guess it's the opposite, kind of, you could say. We can 2 potassiums to balance out the SO4. Yep. And those are all neutral. So now we'll just check for same elements. Cu, 1, 1, SO4, 1, 1, K. There's 2 Ks over here. And so we're going to put a 2 right there. Now we have 2 potassiums, 2 potassiums. 2 OH, 2 OH. 1 copper, 1 copper. 1 SO4, 1 SO4. So that's all balanced and good. Now on this side, we're going to figure out which one is going to be the quote-unquote product and which one's going to be aqueous. I'm not sure if they're going to give you a solubility chart when you do these problems. Sometimes they will, sometimes they won't. If they do, that's easy enough. You can just look it up. If they don't, it's sometimes decently easy to just pick out a few trends that are easy to memorize and then use them here. So in this case, I believe the CuOH is going to be insoluble. So that'll probably be a solid or whatever. And the K2SO4 is going to dissociate. And I think that will be the case. Let me just double check. Yep, so this is going to be 2K plus SO4 minus 2 minus. Yep. And going to have 2K there. And a 2 OH. A lot of skinny 2's going on here because I'm writing in pen. Okay, now the net ionic, we're just going to take that product, throw it on the other end. Cu, the thing that actually formed. And then give it whatever it had. So the Cu is going to be the 2 plus OH minus 2OH minus. And that should all balance out. And the charges look good because we have the +2 from the copper and then -1 from the OH, and then so you have 2 of them, so it's a total of -2. So that one worked out pretty good. Now here's one that I think should be the least, I guess the most challenging, or you could say the least convenient of them, because I think the exponents are going to work out a little bit funny. So molecular, ionic, net ionic. So for the molecular, again, copy it down. Na3, PO4. This one has the states of matter too, so that'll be good. CaCl2, aqueous. Again, leave some space. What I like to do first, like I said previously, just write the charge and then worry about the exponents after. So Na is always going to be the 1 plus. Then we have plus the PO4. I think this is a phosphate, right? So phosphate's a 3 minus. Plus the calcium. Calcium is, I believe, a 2 plus. Plus Cl is a 1 minus. We have 2 Cls. Now I write these in 3 NAs. So again, we'll do the what's it called? Rearrangement there. The cation from one with the anion of the other. It's going to be NaCl, table salt. NaCl. It's going to be one of them, and that we can know logically that it is going to be soluble in most solutions. But you can also use the solubility rules if you know them, and that will also prove that. NaCl, so we can balance the numbers after. Plus, calcium's going to go with the phosphate. Let's check out the charges. So the NaCl worked out because Cl's minus and Na's plus. But for the calcium and the phosphate, I don't know if it's going to work as well. So this is a 2 plus, this is a 3 plus. So the only way we can do it, you could again do the swap. I don't know if that would work. Yeah, it would work here. So you can just cross the 2 and the 3. But you can think about it mathematically too. So for the Ca, I always start with the cation. In order to get to 6, which is the least common multiple, you're going to need 3 of them. So Ca3, and then PO4 you're going to need 2 because it's a negative 3. 3 times 2 is 6. And then put those parentheses up there to indicate that you're not talking about the entire molecule. This portion of the molecule, I guess you could say. So the PO4, 2. Cool. So now we have to balance. Obviously, there's going to be some issues because there's 3 sodiums here and only 1 here. So that's probably the quickest way to do it. Let's see. So yeah, this is why this one's tricky, because we're going to have to do probably 6, I think, because if we add 3 right here, if we add 3 right here, that's going to be 6. So I think what's going to happen is, let's see, if we put 2 here, so we're going to get 6 sodium, 2 PO4, and then we're going to need to do the Cl. If we put a 6 here, we have 6 sodium on both sides, and then chloride, we have 6 over here, 2 over here, and 2 times 3 is 6. There we go. So we got 3 calcium, 6 chloride, because 3 times 2, 6 chloride. 3 times 2 is 6 sodium, and then PO4, we have 2 PO4, and then here we have PO4 too. So that's all balanced. There we go. Okay, and the states, I'll throw those in. So NaCl we know is going to be aqueous, and that means this is our solid product. So here we go. Pull through with the, let's see, Na plus Cl minus plus. And the way I learned it, we did not need to write the actual charge on whatever the product's going to be, whatever we're counting as the solid product. So now we just balance the numbers. Now these don't match, but we're going to have to do them so we can make a match. So 6 Na over here, 6 Na over here, 2 Cl. I'm not sure if I can make that a 6. 6 Cl, 6Cl. Now PO4, we're going to need 2 PO4, and we're going to need 3. It's a lot easier when they're all spread out like that. Okay, so now for the net ionic, easy peasy. We're just going to throw only the thing that we actually formed that didn't dissociate in the ionic formula. And solid, whatever. I don't think you need these for each step, but then we're going to add Ca2+, 3 Ca2+, plus the phosphate, which we need 2 of. Cool. So yeah, hopefully this helped someone. These are just 3 examples. Let me know if there's some questions or anything I did wrong. Yeah, hopefully this helps.